Hi folks, this is Calc 2 Take Home 8. We're asked to find the Taylor series for cosine centered at x equals pi over 2. So we can make up our little chart here. N, the nth derivative at x, the nth derivative at our center, which is pi over 2, n factorial, and the nth derivative at the center divided by n factorial. This is how we build our little coefficients here for our Taylor series. Alright, so this grid has much to be desired, as long as it keeps me a little bit organized. Alright, so n equals 0, 1, 2, 3, and 4. 0, 1, 2, 3, 4. So the 0th derivative of cosine is just cosine itself. Then we start taking derivatives. And they repeat in a cycle of 4, as we expect. We'll substitute in pi over 2. The cosine of pi over 2 is 0. Sine of pi over 2 is 1. Cosine is 0. Sine is 1. Cosine is 0. 0 factorial is 1. 1 factorial is 1. 2 factorial is 2. 3 factorial is 6. 4 factorial is 24. And I get 0, negative 1, 0, 1/6, 0. And so let's see what this gives us for our Taylor series. So we ignore the first term. So the first non-zero thing we get is negative 1. So we get negative 1 times x minus pi over 2 to the first power plus 1/6. This would be x minus pi over 2. Oops. To the third power. We'll do one more here, 5, just to get the flavor of it here. I'd have minus 1 over 120, x minus pi over 2 to the 5th, and so on. So we can pick up the pattern here. All the even powers are going to disappear. We're going to be left with all the odd powers. Moreover, the coefficients are going to be alternating, negative 1 to the n over n factorial. So we could say then for our final answer that the Taylor series is summation. We could start n equals 1 to infinity. We have negative 1 to the n power x or over the odd factorials, so that would be 2n minus 1 factorial x minus pi over 2 to the 2n minus 1. All right, that's one way to do it. Or if we wanted to start the index at 0, it would be negative 1 to the n plus 1 over 2n plus 1 factorial x minus pi over 2 to the 2n plus 1. Now, you might be a little curious. These coefficients look hauntingly familiar. And the reason they look hauntingly familiar is because there's an identity in here, a trigonometric identity, that relates sine and cosine. So I'll leave that to the interested reader to figure out why these coefficients are so hauntingly familiar. And that'll do it for Take Home 8.